All right, so what we got going on here is temperature scales. Okay, we already talked about other things about temperature, but what we're doing now is temperature scales. Now, there's three. You've got them right there. You've got Fahrenheit, you've got Celsius, and you've got Kelvin. Fahrenheit is what you're most familiar with. Celsius is what you're somewhat familiar with. Kelvin is about the same as Celsius, but let's talk about this a little bit. Okay. First of all, when you're talking about Fahrenheit, it was named after this guy, Daniel Gabriel Fahrenheit. So he first proposed this in 1724. It's not the most scientific thing, but he said right here, 0 degrees Fahrenheit, that's going to be the coldest day that he records in his place in Germany. So that's just kind of how he did it. And then he said 100 degrees will be the hottest day. So not so bad. At least you're setting some sort of standard, but that doesn't really work when you try to set the same standard in France, or if you go down to Italy, or if you go to Africa, or if you go, well, anywhere else in the world. It's not very scientific, but it is a start towards some sort of degree scale. Also, I mean, is it the coldest day in the first 10 years, the second 10 years, all 40 years, all 60? I don't know. But at least it started us in measuring temperature. The next one is Celsius. Now, this was an improvement, and it wasn't that far away. It was around 1742. It was named after Swedish astronomer. See, astronomers are pretty smart too. Anders Celsius, and that was around 1742. He did it. He had a better standard. He used water. And water has been great. We already talked about water and its specific heat capacity and all that. He said, okay, 0 degrees is going to be water's freezing point. Wherever water freezes, that's the point. We're going to say 0 degrees is that. And then he said 100 degrees is going to be water's boiling point. Right? This is a lot better because if you bring water here, if you bring it to France, if you bring it to Italy, if you bring it to Africa, it's basically going to boil and freeze at the exact same point no matter where you are. That's what makes this a whole lot more scientific. It allows more people to be able to use it. Is it exact? Not quite, because water boils and freezes at different sea levels, or different, elevation levels. There's only one sea level. But the idea here is that really what it winds up being is the water and boiling point at sea level. Okay, and then you can adjust that very easily for whatever your elevation above sea level is wherever you're at. That's why they say it usually takes longer to cook, or takes less time to cook in higher altitudes, because the boiling point, longer to cook, because the boiling point is lower because there's less air pressure, and therefore if you're boiling something, it's at a lower temperature, so you need more time to cook. Now, again, this is much more reliable, but there are some adjustments to make. See, we said temperature is the average amount of kinetic energy of the molecules, right? But as far as kinetic energy goes, if 0 is the freezing point, is this saying that there is 0 kinetic energy? Well, no, you can't have 0, or really, let me put it this way. Can this be saying that if you are at negative 20 degrees Celsius, do you have negative kinetic energy? Well, no, we can't really say that. Okay, so that's where Kelvin comes in. So basically, I keep Celsius up here because it's basically the same thing. But Kelvin, it was named after the Scottish physicist and engineer William Thomson, the first Baron Kelvin. And again, it's the same scale as Celsius. And what I mean by that is that there's 100 degrees between boiling and freezing, or freezing and boiling. Same, except it's shifted for absolute 0. Okay? 0 degrees is now absolute 0. And see, absolute 0 is that point at which there is no thermal motion whatsoever at all. We've never reached it. But we've gotten down to about 1 times 10 to the negative 10th Kelvin. That's as close as we've gotten, which is pretty darn close. Not bad. Let me explain what I mean a little bit more visually. This usually helps me a lot more. Okay? If you take a look at this, you will see water freezes at 32 degrees Fahrenheit. Okay? And it boils at 212. Now, what that shows us is that there are what is it, 180 degrees in between freezing and boiling. Now with Celsius, though, there's 100 degrees between boiling and freezing. So they're different scales. All right. Guess I'll have to stop there. I'm back. Now, they're different scales. Now, what that means is that there's 180 between boiling and freezing here. There's 100 between these two. But physically, they're the same temperatures and there's same difference. And it just so happens that if you take 180 and you divide it by 100, you get 9/5. And likewise, if you do 100 divided by 180, you get 5/9. That's going to be important in the next little bit. So, if you take a look, all right, if you take a look down here, absolute zero, where all thermal motion stops, is negative in both Fahrenheit and Celsius, and it's negative 459 in Fahrenheit, and negative 273 in Celsius. So, the thing is that if all thermal motion stops, and temperature is a scale of the amount of kinetic energy of the molecules, you can't have this negative here. It's got to be zero. So that's really all that Kelvin does, is it takes this Celsius, this zero, and just shifts it down here. So it's the exact same scale. It's just that everything is shifted down. So now water freezing is 273 and water boiling is 373, but there's still a 100-degree difference. And now this is why at the small scale, Kelvin doesn't really do much. Okay, Kelvin is very, very similar to, at the low scale, there's a 273-degree difference. But as you start getting higher and higher in the temperatures, when you're getting into the millions, notice 10 million Celsius is just about 10 million Kelvin. This is where hydrogen fuses, about the temperature of the core of the sun. It's only a 273-degree difference, so there's really not much difference between Celsius and Kelvin there. However, because of the scale difference, because of the 9/5 scale difference, the Fahrenheit is very different because of the scale difference, not because of the shift. Okay? So, I think that's really all I want to talk about, except how do we actually convert from one to another? And I mix these up, so you can have these on your essential equation sheet if you want. Okay, so let's just talk about Fahrenheit to Celsius. Okay, so if we're talking about Fahrenheit to Celsius, we need to talk about, let's see, well, let's just put it this way. The Celsius, the degrees Celsius will equal, well, first of all, you've got to take whatever the Fahrenheit number is and subtract 32. Okay, that's because you got to go from 32 down to 0. There's that 32-degree shift where 0 and 32, they're just a bit off. And you've got to take into account that scale difference, which would be 5/9. Okay? So to convert from Celsius to Fahrenheit, from Fahrenheit to Celsius, you just take whatever the Fahrenheit is, let's say it's 32, and you subtract 32, 32 minus 32 is 0, and multiply that by 5/9, that's still a 0, so it works. Same thing here. If 212 is Fahrenheit, 212 minus 32 is 180, and 5/9 of 180 is 100, so that works out as well. Now you could just do some algebra to get the opposite way, but I want to show you that to find Fahrenheit when given a Celsius number, all you do is you got to flip this, and you take 9/5 of the Celsius number, and then add 32 after you take the 9/5. That way you're adjusting for the scale difference as far as the difference between water boiling and freezing, and then you add 32 for that shift. Now the easiest ones are Celsius and Kelvin, okay? So just think Celsius water freezing is 0, and water freezing is 273 in Kelvin. So really, all you got to do that is say, all right, my Celsius, oops, that's bad, but Celsius, no, scratch that. sorry, Kelvin, degrees Kelvin, equals whatever Celsius is plus 273. That's it. So Kelvin is whatever Celsius is plus 273. And so to go backwards, all you got to do is say Celsius is Kelvin minus 273. And that's it. You'll want these on your essential equation sheet. You're going to do a worksheet on this as well, so make sure you write it down. And if you have any questions, see me in class.